Hello everyone! In the coming two videos, we are going to have a look at what is called measures of spread. Now, previously we have seen measures for the middle, the center, the average. We've seen that we can calculate the mean, what we would usually call an average, that we can find the median, and that we can find a mode. But that doesn't tell us everything about the data we have. It doesn't tell us how far the data is spread around this middle, around this center. And that is what measures of spread tell us. So to start with a small example, suppose for a certain test, the mean grade is a 6.5. That is a pretty decent mean for a grade, but we don't know what that actually tells us about the group. Maybe everyone had a 6.5. Seems a bit unlikely, but that's perfectly fine grade. But it could also be the case that half the class had a 3 and half the class had a 10. Then also our mean grade would be a 6.5, and that's an entirely different situation. So what we're looking for is something that tells us which of these cases we're in or whether we're somewhere in between. And that's what we're going to look at. In fact, we're going to look at two different measures of spread. One that has to do with the mean and one that has to do with the median. So let's start with the mean. And for the mean, we're going to get the mean deviation of the mean. Well, what is that? The mean is our average. The deviation means how far away from the average are we. So this is asking, on average, how far away are we from the average? Let me just type that out. Which sounds a little silly, but we'll look at a proper example in a moment. In the example at the top, the mean was 6.5. So if everyone had a 6.5, our mean deviation of the mean is 0 because no one was anywhere away from the average. Everyone had the mean grade. On the other hand, if half the class had a 3 and half the class had a 10, then everyone's grade was 3.5 away from the average. So our mean deviation of the mean would be 3.5, very high, which tells us that the grades were very spread out and not very close to the actual mean. So that's the first one. We'll look at a proper example in a moment, but let's also have a look at the second one. And the second one has to do with the median. And to remind you, the median is the middle number if we order everything from lowest to highest. And for the median, we have a look at quartiles. So you have the quartile 1 is kind of the median of the first half. So the middle point of the first half of the data. Similarly, the third quartile is the median of the second half. It's the first and third because you can kind of consider the median as the second quartile, but we don't call it that. So this gives us some idea of how spread it is again, and gives us some more information as well, because it also gives us what is called the interquartile range, which is the difference between those two. And lastly, when we're on that topic anyways, we can also just have the range, the full range of our data, the lowest value, the highest value minus the lowest value. So in this case, with our grades, if half the class had a 3, half the class had a 10, our median would still be right in the middle, would still also be a 6.5 in this case. But the first quartile would be 3, because in that first half, everyone had a 3, so the middle one is also 3. And the third quartile would be the middle point there of the second half, so that's all 10s, so the second quartile would also be 10. So both the interquartile range and the actual range would be 7, 10 minus 3. But that was just this very specific example. Let's look at a more general example where I will use this table of grades. As you might see, I've already added another column that I'll need in a moment. What I've already calculated for this one is that my mean, by calculating like 2 times 4, 4 times 5, 6 times 6, and taking the average, my mean is 6.6. So let's have a look at that mean deviation of the mean. But then I first need to know the deviations. So that's what I'm going to use this column for. The grade 4 is 2.6 away from my mean. The grade 5 is 1.6 away, 0.6, etc. 7 is 0.4 away from my mean. 1.4, 2.4. So then I have to calculate the average of these. I have 2 values of 2.6, 4 values of 1.6, 6 values of 6.6, etc. And I calculate the average of that. So what I do, my mean deviation of the mean, I calculate my 2 times 2.6 plus 4 times 1.6, etc. Calculate, I add all those deviations together, and I still need the mean. I still divide by the total amount. And in this case, that gives me 1.216. So on average, people are around 1.2 away from the mean grade. And that's pretty decent. And it does make sense with our table. Most people are close-ish, but slightly higher, seemingly slightly higher than the average. And then we have some excesses on the outside, but not very many. So it is relatively clustered around 6.6, and that is what our mean deviation of the mean tells us. So that's one thing. Now let's have a look at the median as well. And here we are going to get into a little issue because we have an odd number, and then there are several different ways of solving it. I'm just going to show one way that works, but sometimes slightly different ones are used. In fact, in the exercises, you will always see an even amount when you're working with the median to avoid any troubles. But yeah, okay. We need to find the median and stuff, and for that we need to put everything in order. So let's just type that out. We have 2 4s, 4 5s, 6 6s, 5 7s, 6 8s, and 2 9s. So my first goal is to find the middle, which would be the 13th value. So this is my median. 7 is my median. And then I need to find the median of that first half. As you see, I'm conveniently ignoring this median here because otherwise I would not have equal parts. That's because we have this odd number to work with. So what happens here, I have 12 on each side. So my first quartile would be right in the middle here. So I would actually say that's 5.5 because it's in between 5 and 6. In the second one, where I have not drawn this very well because I do need to take into account that other 7, my third quartile happens here. So that's, well, between 8 and 8, that's just 8. So let's put that all together. Q1 is 5.5. Q3, third quartile, is 8. And then we have our ranges last of all. My interquartile range is 8 minus 5.5 is 2.5. So the bulk of my grades is only within 2.5 difference from each other. And my full range is, well, highest minus lowest value is 5. Everything is between 5 of each other. Lastly, one nice thing, this does actually match very nicely here. If the lowest and if the bulk is between 2.5 from each other, that is just both sides of the mean. So that kind of makes sense. But that is just some more rationalization, which doesn't always work. But yeah, these are the terms for measures of spread. In the next video, we're going to have a look at how we can visualize this nicely in what is going to be called a box plot. But for now, we're first going to get used to working with these terms in the first place.